I can identify opposite, adjacent, and hypotenuse in a right triangle and find trig ratios. So let's take a look at our first example. And there's really 4 steps we're going to follow here. We're always going to circle the reference angle. The reference angle is either going to be this angle or this angle. It will never be the 90 because trigonometry is only going to work here in right triangles. So this will never change, but these angles will change. And which one we refer to matters. So the reference angle I'm talking about here happens to be R. So I'm going to go ahead, I'm going to circle R and shade in that angle. Now the hypotenuse is always the longest side and it's opposite the 90 degrees. Biggest angle, opposite the biggest side. Okay? So this here will be the hypotenuse, which I'll abbreviate that way. The opposite side, opposite from what? Well, the answer is opposite from the angle we're referring to. So if you think of this as a light, when the light turns on, it shines its way across to the opposite side. And this is opposite angle R. And finally, adjacent means next to. And you might say, well, what's next to angle R, the reference angle? Both these sides are next to it. But this one already has a name, so we're going to call this one the adjacent. Being able to label a triangle as reference angle and the sides this way really matters. Please keep in mind 90-degree angle is never a reference angle. Okay? Never, never, never. So let's go ahead and do the exact same thing, but instead of coming from angle R, we're going to refer to angle K. So I'm going to bring it over here. You can hit pause and try it yourself. Okay, here I go. I'm going to circle my reference angle. That's the angle I'm working from. Then I'm going to go to the hypotenuse, which is always across from the 90. Notice that doesn't change. The hypotenuse is always in the same spot. What does change, though, is the opposite side, because now side RG is opposite because it's opposite angle K, coming from a different place, different reference angle. And this will be my adjacent. So, zoom out a little bit here. And we want to figure out what's going on. Let's take a look. We have some words here we need to go over. All right, before we do that, trigonometric ratios. Okay, you see the prefix tri for triangle for 3. A ratio is a relationship, okay, and it's going to be a relationship between the sides and the angles of a triangle. But what kind of triangle? A right triangle. Only a right triangle is this going to work for. So let's start here. This you pronounce sine, and F is going to be the reference angle. So I'm going to go ahead and I'm going to circle F. That's my reference angle. And sine now is something we're going to go over as soon as I label the other pieces. Always label your sides. My opposite is across the way here. My adjacent will be here. Now once you've done that, sine, we actually are going to abbreviate it. And we abbreviate sine this way. S-I-N. We don't say sin, we still say sine. And then we just put the capital letter F. Sine of F is how you read that out loud. Sine of F. And sine of F is just a relationship between two sides. The side opposite compared to the hypotenuse. So the side opposite F, again, this is my reference angle. I want the side opposite F compared to the hypotenuse. And in our case here, What side is opposite f? 3, and the hypotenuse is 5. So this is 3 over 5. That's the relationship. Now, cosine of f, all right, is a very similar idea. We're going to abbreviate it with COS. We don't say cos, we say cosine. Cosine of f, this is still my reference angle, is a different pair. It compares the adjacent to the hypotenuse. So for us in this case, the adjacent to f is 4. Hypotenuse is still 5. And finally, the last, tangent. Well, tangent of f, we abbreviate with tan, but we don't say tan, we say tangent. There's my reference angle. And tangent stands for two other sides. It stands for the opposite side compared to the adjacent. The opposite from f is 3. The adjacent to f is 4. So from now on, when we say sine, cosine, or tangent, we need to know where we're coming from. And all of this abbreviation, all it means is that we have a right triangle, and we want to know the side opposite from f compared to the hypotenuse. That's it. Adjacent and hypotenuse, opposite and adjacent. So notice here, though, I switch my reference angle. So you can hit pause and try this on your own and try and do sine of L, cosine of L, and tangent of L right here. Here I go. First thing I'm going to do is I'm going to circle my reference angle coming from L. Hypotenuse is going to be the same. My opposite, however, is now over here, whereas it used to be up here. See? And my adjacent is now going to be down here. The numbers stay in the exact same spots. It's just that this is now the side opposite from my reference angle because I changed reference angles. So now I want sine of L, cosine of L, and tangent of L. Sine of L happens to be opposite over hypotenuse. Okay, opposite over hypotenuse. And so for us, opposite is 4, hypotenuse is 5. You would reduce if you could. Cosine of L, adjacent over hypotenuse. And the adjacent is 3 over 5. Adjacent is 3, hypotenuse is 5. And finally, tangent of L. Again, these are all my new reference angles. Tangent is my opposite, which is 4, over the adjacent, which is 3. And there we have it. So how are you going to remember these? Which one sine is, which one cosine is, which one tangent is. And here's a quick way to remember. So, ka, toa. So stands for sine. The S stands for sine. The C here stands for cosine. The T here stands for tangent. These other letters, though, stand for opposite over the hypotenuse. The A stands for adjacent over the hypotenuse. And the O stands for opposite, and the A for adjacent. So you want to write so, ka, toa at the top of every single page. It'll remind you what sine actually means, what cosine actually means, and what tangent actually means. So if I come down here now, write the following trigonometric ratios using segment notation. We're going to do exactly what we did before, but with only letters. There's no numbers on the sides. So you want to start like you did. Here's your reference angle for the first 3. It's going to change over here. But I'm going to circle my reference angle to start. And you're going to go ahead and you can hit pause and try this on your own, but I'm going to mark up my hypotenuse, my opposite, and my adjacent. And then I'm going to go ahead and remember sine is so, meaning opposite over hypotenuse. The sine goes with the s. Over h, opposite over hypotenuse. The opposite is jd. The hypotenuse is dy. Done. Cosine of y. Well, that's ca. Cosine, c for c, is adjacent over hypotenuse. So the adjacent is jy, and the hypotenuse is still dy. Finally, tangent is toa. It's opposite over adjacent. Opposite is jd, and the adjacent is jy. You can go ahead and try the next one on your own. Some people, however, like to re-sketch this because we're switching where the opposite and the adjacent are. So you might be tempted almost to break this into two mini problems. Still call this J and Y and D. It's kind of up to you. This makes more sense to you. This is still the hypotenuse. It's just that my reference angle is from D now, whereas it used to be from Y. Now it's down here from D. So some people like to re-sketch it to keep it clearer, because this is my opposite now, where it used to be the adjacent, and this is my adjacent. Whatever helps you. Sine of D, sine, the S goes with the so. That's opposite over hypotenuse. So we can go ahead and say the opposite from D is jy. My hypotenuse is dy. Cosine is ca, meaning adjacent over hypotenuse. So you're looking at from D, the adjacent is jd over dy for the hypotenuse. And finally, tangent is opposite over adjacent. So it's going to be jy over jd. So the last couple you can try on your own. These should say A, B, C, D. Sorry about that. What is cosine of B? You can go ahead and try these on your own right now if you'd like. This letter down here, by the way, should be a P. But very quickly, cosine of B, here's my reference angle. All right, if you haven't paused it and tried it, you should. It's my reference angle. I'm always going to label my sides. It'll really pay off. When I get tired, I'll make fewer mistakes. Okay, cosine of B, cosine, cosine, cosine. That's SOHCAHTOA. That's C for cosine, meaning adjacent over hypotenuse. So I'm going to come back down here and I'm going to look for the adjacent, which is 8. So cosine of B is equal to 8 over the hypotenuse, 11. There we go. And then I try this one. What is sine of Q? Q is the reference angle. Hypotenuse is always the same, but this side is my opposite, whereas this is my adjacent. And so I want sine of Q, sine, the S for so, opposite over hypotenuse. So the opposite over the hypotenuse in this example here is going to be what? Opposite is VP, and the hypotenuse is QP. See if we can find that. Could be in reverse. VP is the same as PV. No. No. VP, QP. Done. Make sure to mark up your diagram, and particularly your reference angle every time, and you'll be fine. Good luck.